I am the tofu golem. Please enjoy the video.
You start by confirming what each axis shows: temperature on the x-axis and solubility, G per 100 G solvent, on the y-axis. Once done, make sure units match your conditions. Convert if necessary. Next, find the curve for your specific solute or plot your experimental point. You need that baseline to compare. If there are multiple curves, trace the correct one slowly, and keep your finger on the temperature value you care about so you don't lose context as you proceed. You now use the curve to read exact solubility at your target temperature by moving vertically from temperature to the curve, then horizontally to the y-axis. Once there, decide saturation. If your added solute mass equals the curve value, it's saturated. Less means unsaturated. More indicates supersaturated or excess precipitate. If the temperature falls between grid marks, interpolate linearly between neighboring points to estimate solubility. This gives you the practical amount of solute that will dissolve under your conditions. You finish by predicting whether cooling will cause precipitation. Follow the temperature change horizontally and see if the solubility drops below your dissolved amount, precipitation follows. To recover a clear solution, warm to increase solubility or add more solvent. If results don't match expectations, troubleshoot. Verify units and that you read the correct curve, confirm sample mass and measurement accuracy, and repeat a key point. Small errors in axis scale or units are the only way readings go wrong.
Thanks for watching. Consider subscribing if we helped you today.